Hello, ladies and gentlemen. Today is graphing and understanding solutions to linear equations. Alright, by the end of the lesson, we want to be able to say this. I can solve linear equations with two variables. That means I can find solutions to linear equations. Secondly, I can graph linear equations using ordered pairs. I think all of you can actually do these two things. Hopefully this is more of a refresher than it is a lesson. Okay, so for starters, let's talk about some wordage here. A linear equation in two variables is an equation in which the variables appear in separate terms. That means there are two separate variables, and neither variable contains an exponent other than 1. This is very important. We cannot have a linear equation if one of our variables has an exponent that is something different than 1. Just as a side note right here, I put it in parentheses and I'll star it. When you graph these equations, when you graph linear equations, they will always appear as straight lines. If they don't, then you either don't have a linear equation or you've graphed it wrong. Okay, guys, that's very important. That's an easy check for yourself when you're graphing. So, a couple examples of linear equations. You guys have seen these before. Y equals 1.5x, or y equals x minus 4, or 2x minus 4y equals 0, or y plus 119x equals 36.24. All of those examples, there are many, many, many more you could come up with. All those four examples meet our definition of a linear equation. Okay? The variables appear in separate terms, which means you don't have x times y. Okay? If you notice, our terms are separated by a plus or minus sign. So the y is in its own term, the x is in its own term. And our exponents of our variables are always 1. Okay? You'll find out when we graph these things, yes, they would actually form straight lines. Now, a couple examples of nonlinear equations. Very simple. Y equals x squared. Yes, there are two variables, but we have a violation of one of our rules of a linear equation. Our x, our one variable, has an exponent that is other than 1. It's 2. So this guy is not a linear equation. Also, same thing over here. Y squared plus 1.5x equals 6. Well, our y has an exponent that is something different than 1. So this guy cannot be linear. If you were to graph it, you would find that it's not going to form a perfectly straight line. Alright, one more piece of wordage here. Solutions of linear equations. So remember up here I said I can solve linear equations with two variables. That means I can find solutions for my linear equation. Okay? Solutions of linear equations are ordered pairs. But they're special. They're ordered pairs that actually make the equation true. So if you're asked to find a solution of a linear equation, I'm looking for an ordered pair. Okay? So let's jump right into a couple of examples here. Number 1 says, find 4 solutions of y equals 1.5x. Well, I'm asked to find 4 solutions. That means I'm going to have to find 4 ordered pairs that make this guy true. This is done very simply. All we have to do is pick any 4 numbers we want. I've chosen 4 here, negative 1, 0, 1, and 2. But you can choose any 4 numbers you want. I don't care if you choose different ones than me. Let's plug them in here to the x column, and then let's do them one at a time. So if you were to plug in negative 1, whoops, my pen's kind of frozen. If you were to plug negative 1 in for x in this equation, you would end up with, and I'll show some work over here, y equals 1.5 times negative 1. That's correct, isn't it? Or if you simplify this, it's just y equals negative 1.5. So when x is negative 1, that means that y is negative 1.5 in this equation. So same thing, let's plug in 0 for x. Well, 0 times 1.5 is going to be 0, so y is 0 when x is 0. When x is 1, so let's plug in 1 for x, what will y equal? Well, what's 1.5 times 1? It's 1.5. Okay, so this is pretty simple right here, guys. We're choosing any numbers we want. We're plugging them in for x into our equation, and that's just spitting out a y value. So 2 times 1.5y better equal 3. So 4 solutions of this equation, and you might have different answers than me if you chose to use different numbers, are 1, negative 1.5, 0, 0, 1, 1.5, and 2, 3. Okay? You could have come up with an infinite number of ordered pairs, but I chose those numbers for x. The question is, are these the only solutions to this equation? And I just answered that. The answer is no. Okay? You can, and I would write this down if I were you, there are an infinite number of solutions. There are an infinite number of solutions. Okay? And you can continue to make my table bigger over here and just add numbers in for x. 3 and 4 and 5 and 6 and 7 and 8 all the way up to a trillion. And each one you'll plug in for x and you'll get a different y value. Okay? So there are an infinite number of ordered pairs that make this true. Let's move on. Number 2 says, pizzas cost $9 and a special type of cups cost $1 per cup. Find 4 solutions of this equation in terms of the number of pizzas x and the cups y, 2 important pieces, that Mr. Dudek can buy for his Christmas party with $90. Then we have to answer the all-important question. What does each solution mean? Okay, so we're told that we have this linear equation right here. And this represents the number of pizzas I'm going to be able to buy. Pizzas are represented by x. And the number of cups that I'm going to be able to buy, represented by y. And we're saying that however many I buy, obviously, can only equal $90. That's all that I have to spend. Okay? So find 4 solutions of this equation. Well, let's make this easier on ourselves. In the first example, it was very easy because we already had y by itself. So that meant whenever we plugged in a number for x and we simplified, we already had y equals whatever our answer was. So let's make this easier on ourselves and let's solve this equation for y. Let's get y by itself. So I'm going to show some work. I'll do it right here. So 9x plus y equals 90. If we want to get y completely by itself, I'm going to subtract 9x from both sides. And you guys are like, what the heck am I supposed to do on the right side, Mr. Dudek? I'll even make my dashes here. So 9x minus 9x is 0, but you're left over with y, and of course our equal sign. And 90 and negative 9x are not like terms, so you cannot combine them. Okay, so you need to write in here, this is as simple as you can make it, y equals negative 9x plus 90. Or you could have written, if you preferred it, 90 minus 9x. Okay, that's the same thing. Now, we've made this easier on ourselves. I'm going to write it in here. Negative 9x plus 90. So that now when we plug in our values for x, it just spits out a y value. So if you plug negative 5 in for x, you have negative 9 times negative 5, which is positive 45. And then we're going to add 90 to that and get 135. Let's plug in 0 for x. Well, 0 times negative 9 is 0. Plus 90 is 90. And then we plug in our other two values, and we should get 81 and 72. Okay, so I broke this down into steps for you. We got y by itself, then we chose 4 x values and substituted them into our new equation. I chose the x values for you. Once again, you could have chosen whatever 4 values you wanted. Okay. Lastly, C. We have our solutions, our 4 solutions, and I want to know what the heck those things mean. Because in math, yeah, we deal a lot with just random numbers and variables, you guys think, but we're trying to build you up so that eventually we can start to interpret we can start to apply these skills that we're learning and use them for something. Not just to deal with numbers and variables, we actually want to use them in real situations. Okay? So, negative 5, 135, we're going to come back to that one. 0, 90, what does it mean? Well, I would write all this down. I'm going to write in shorthand because I'm writing on the Mimeo and it's tougher. Okay? What does X represent? It represents the number of pizzas that I purchase. And 90 is my Y value. It represents the number of cups that I purchase. 090 is a solution that works in this equation, which means technically I could buy, with my $90, I could buy 0 pizzas and 90 cups, right? I could buy, doesn't mean I'm going to, doesn't mean it's the best idea, but I could buy 0 pizzas and 90 cups. Be a pretty lame party if I just had 90 cups and no pizzas. Okay, maybe you now know what this solution represents. Since our X value is 1, that means I purchase 1 pizza, and with my leftover $81, I could buy 81 cups. So it's the same answer as above, except for it's, I could buy 1 pizza. If I did that, then I could still buy 81 cups, and I have enough money to do this. I couldn't buy 1 pizza and 82 cups because I don't have $91. I only have $90. So you get the idea, I think. But let's go back up here. What in the world does this mean? Negative 5, 135. Does it make sense to say that I could buy negative 5 pizzas? Does it make practical sense is really what I mean? That I could buy negative 5 pizzas and 135 cups? No, it does not. Okay? Now, this is something you need to pay close attention to. So that doesn't make, oops, I was supposed to cross that out. It doesn't make much sense. Negative 5, 135 is a solution of my equation here. Okay? But sometimes when you get a solution in math class or in a real situation, it makes mathematical sense, but it does not make practical sense. So this is why it's so important to understand what our variables represent. Okay, in this case, X is pizzas and Y is cups. If you don't know what your variables represent, you're not going to know if your answer makes logical, realistic sense. Okay? So negative 5 pizzas is unrealistic, so this is an answer we're not going to use. Okay? Because it does not make real sense. Alright, let's continue on here. Last one. A linear equation can also be represented by a graph. Okay? So you guys know that you can represent a linear equation or you can write it in equation form, as we've done here. This is an equation. These are all equations. Okay? But you can also represent this linear equation as a graph. And that's done so when we plot our ordered pairs, our solutions. So number 3 says graph this guy by plotting ordered pairs. Well, you can choose any numbers you want and plug them in for X. I chose the same 4 that I chose on the last one. Okay, so if you do this, and you plug in your numbers for X, you should get negative 3, negative 1, 1, and 3. Guess what? Those are 4 solutions. Now I can graph these things. Negative 1, negative 3 is right there. 0, negative 1 is right there. 1, 1 is right there. And 2, 3 is right there. If you notice, those line up perfectly. Well, if I was a better artist, they would line up perfectly. And obviously my line is going to be terrible. But guess what? If you draw a line straight through those guys, you have a linear equation. Remember, what did we say that a linear equation will always look like when graphed? We said, way back here, I started. If you graph these equations, they'll always appear as straight lines. Yes, I know this doesn't look like a straight line. But if you took a ruler and you were actually drawing with your pencil, and you drew it through a straight line through all those points? Yeah, it would be straight. Those points line up perfectly straight. This is proof that this is a linear equation. If you graph this and you did not get a straight line, it wouldn't make sense. Okay? So once again, I broke this down into steps for you, but I kind of moved through it quickly because I know I'm taking a while here. Find some solutions to your equation. Step B says graph these solutions and draw a line through them like we did. Now, step C says, please note that the ordered pair for any point on my line is a solution to my equation. Okay, that means, once again, that I can plug in any number for x, and I'm always going to get a y value that corresponds to that x value. That means that how many solutions are there to this linear equation? There are an infinite number. That's why I put arrows on the end of my line here, okay? Because that means this line goes on forever and ever to the left and ever to the right, because you can keep adding more and more points, okay? I'm going to have you read that takeaway on your own, but I think the most important thing here is the first one. Okay, there are many ways to represent functions. Okay, there are many different forms you might run into. One of those forms in which you might see a function represented is in its graph form, right here. You might run into a function that's represented in a table, but guess what? This guy is the same as this guy, isn't it? It's just represented differently. And you might run into a function that's represented, or that's portrayed as an equation right here. Guess what? Actually, this one, and this one are all exactly the same. They're just different ways of portraying this function. You need to be able to interpret all three, though, okay? So you're on your own. Sorry, I know that was a couple minutes.